This section of the course is all about sets. Sets in Python are an unordered collection of unique values. Now, when I say values, you'll often hear of it as elements or objects. Due to the fact that sets can only contain unique values, they are particularly useful for tasks that involve membership testing or removing duplicates from a sequence. In GIS and data terms, sets are fantastic for returning unique attributes from a field. As mentioned, a set is a collection of unordered unique values. These values can be a string, numerical data types, or a tuple. In other words, it must be an immutable data type. Sets themselves are mutable. This means that they can be altered in place. However, although sets are mutable, the elements inside a set cannot be altered. We can add and remove values to and from a set, but we cannot alter a value or object inside the set. A set is also iterable, meaning we can cycle through each element or object in the list. It is very important to note that sets are unordered. There is no guarantee the order of the elements, objects, or values returned each time you cycle through a set. Sets in Python adhere to set theory. You might have come across these in school where we used Venn diagrams. So let's say we have two sets of numbers, 1, 2, 3, 4 and 5, and 4, 5, 6, 7 and 8. We can see two common numbers in each set. These are 4 and 5. If we were to call the union of these two sets, we would not have a duplicate 4 and 5. The whole set would be 1, 2, 3, 4, 5, 6, 7 and 8. And this is the union of our two sets. The intersection of our two sets is the number 4 and 5. These are the numbers that were common to both sets. The difference between our set on the left and our set on the right are the numbers in the set on the left that are not in the set on the right. So we are left with 1, 2 and 3. And this is called the difference. We also have symmetrical difference. And this is every number except those in the intersection. You could think of it as the negation of the intersection. Here we are left with 1, 2, 3, 6, 7 and 8. Now, there are other operations that can be performed on sets, and we're going to see some of these throughout this section. Let's head over to PyScripter and see how we create sets with Python. Similar to a dictionary, we also create a set using curly braces, but there is a notable difference. We saw in the last video that we created an empty dict and we set it equal to curly braces. When we checked the type of our empty dict object, we saw that it was a dictionary object. We're going to define a set called num_set and set this to equal curly braces. And automatically you'll think this is going to be a dictionary. But if we supply in comma separated values rather than key value pairs, it creates a set. Now when we check the type of our num set, we have a set object. We can also create an empty set using the built-in set function and hit enter. Now when we check the type of our empty set, we have a set object, and if we print the empty set to screen, we have set and empty parentheses, and if we printed our empty dict, we get an empty pair of curly braces. I'm going to print the num set to screen. We can see our unique values. Later on in this section, we are going to see some set methods. One of those is the clear method, which will remove all values from a set. Now when I print num set to screen, we can see it does not return an empty pair of curly braces. It returns set and empty parentheses. This is how we can differentiate between an empty set and an empty dictionary. Let's recreate the num set and add more numbers. So we'll set this to equal our curly braces and we'll go 2, 1, 4, 5, 2, 3, 1, 1, 2, 4, 5. And hit enter. We've created a set and we've added in duplicate values. So what do you think is going to happen when I print the num set to screen? Remember, a set is an unordered collection of unique or distinct values. So when we call our num set and hit enter, we have returned 1, 2, 3, 4 and 5. Don't be fooled that our printout has 1, 2, 3, 4, 5 in order. If you are using a different IDE, this might not be the case, and this could just be PyScripter ordering those values for us. It is important to remember that sets are unordered and there's no guarantee the order of the values inside the set. We use integers in our example so far. We can also create a set that contains any immutable data type. We'll create a variable called mixSet and set this to equal our curly braces. We'll create a string and we'll just use the text string. We'll create a tuple with 1 and 2, an integer with 10 and a float with 175.9. Hit enter and print our mixed set to screen, and we have all our values inside our set. We can also cast an iterable to a set. We could cast a string, a tuple. Here we're going to use a list. We'll create a variable called counties_list and we'll set this to equal our square brackets for our list, and we will use strings representing some counties of Ireland. We'll start with Kildare, Dublin, Carlow and Meath. Then duplicate Kildare and we will duplicate Meath and hit enter. In GIS terms, we could have grabbed this list of county values from a field in a feature class where the field's name was counties, and we want to get a unique list of the counties from the field. We'll create a variable called counties_set. I'll set this equal to the built-in set function and we'll supply in our counties list variable. We'll hit enter and we will call the counties set variable and print the screen, and we can see we have our unique county values. In this video we got a general overview for the set data type in Python. A set is an unordered collection of unique values. The values in a set must be an immutable data type object.